Welcome to the Arbutus Analyzer tutorial series. This tutorial will discuss how to use the duplicates command in Analyzer to detect records which are not 100% exact duplicates, but are very close, or what we call fuzzy duplicates. Here is an example of a vendor file with an address field. Address fields are notoriously difficult to check for duplicates because of the way they can be entered into systems. If I were to do a standard duplicates test based on the address field, I'll just go to duplicates, I'll choose the address field and select OK. You can see that there are no true 100% exact duplicates. However, one of the things that we have available to us is a function called normalize. And if I edit the table layout, you can see here I've created a computed field called normalized address. The normalize function simply uses an algorithm to try to standardize or normalize the data and make it much easier to compare for exact sameness. You can also include, as one of the parameters, an external substitution table. We've referenced this in other examples before, but this substitution table simply takes commonly spelled streets and gives them a standardized abbreviation. I'll give you an example. I'll pull up this table. All it is simply a text file which has, in the left-hand side, the name as it appears in the address, and then it abbreviates it in the second column over here with what you actually want to end up calling it. So the second column is typically a smaller name than the name on the left. But these are all the various different examples of how an alley might be entered into an address field, and what we'll do is we'll just change or substitute all of these different forms of alley to make them ALY, and that will allow us to do a better duplicates test. Incidentally, these street addresses that I'm using for this substitution table simply provided by the US Postal Service on their website. To give you an example of how this might work, I'll go back to my vendor table. I'll just add this column into my view. And you can see here my computed field has changed the way in which the information looks by applying an algorithm along with the substitution table to uppercase the information, to remove, in this case you can see some of the quotations that were there, some of the extraneous characters like a comma, and in fact the substitution table I've actually removed the word sweet to help consolidate or normalize the data. When I do an analyze duplicates test here on the normalized address, this time it comes back and it has two hits. It finds two matches. And if I drill into this tabular output to take a look at this, we can see the original addresses were added in this manner. You can see they're very different, and this is why they didn't show up with a regular duplicates test. However, after normalizing the data, applying our algorithm and our substitution table, we can see that these are indeed matches. So that's the first way in which we can do some fuzzy duplicates testing, by applying built-in logic, built-in functions like the normalized function. Another example, to extend this a bit further, is the sort normalize. And I'll just add that column into my view. It's already been pre-canned, pre-made here. Again, it's very similar to the normalize function, except now what we do is we take the information and we put it in descending order with the characters first, and then we put the numbers at the end. So this again is another example of how we can standardize or normalize the data to give us a better probability of finding some matches. And if I go back and I use analyze duplicates and I do a duplicates test on the sort normalized field, when I click on OK, it's actually found an extra duplicate or fuzzy duplicate in this data. And the example that it's looking at here is this third one, this PNE. I'll just drill into that. So we can see here, this is how the data was originally stored in the file. Again, no way that's going to show up as an actual 100% duplicate if we just run a standard duplicates test. The normalizing of this data, it got it a bit closer, it's a bit better, but where sort normalize really can help would be in scenarios like this one, where you have a street address and a suite number entered into the data as 801-201 East Pine Street, for instance, or the example above where you've got the 201 Pine Street followed by the suite number at the end. Those are difficult to find exact matches just using the regular address or even a normalized address, but sort normalize puts all the characters first followed by the numbers at the end, and that allows us to do a much better comparison and to actually get a hit, what we call a fuzzy dupe in this case. We've allowed built-in functionality to get those to be a duplicate entry, whereas before we never would have been able to. That is some of the functionality that we have built directly into the product. Another thing that we also have with the duplicates command, I'll just open up a different table here to illustrate this. In the duplicates command itself, if I go to the More button, you can see that a basic duplicates test is doing same, same, same. They're all identical. We also offer same, same, different, which allows you a little bit of a different result. Instead of having to do a same, same, and then list a bunch of other fields and then go through and eyeball it, you don't have to do that with us. We can actually do same, same, different to help isolate those records. And then the fuzzy logic built into the duplicates command actually comes in here with the near and similar functionality. And this is integrated right into the duplicates command itself. So just to walk through how this works, if we wanted to do a test, let's just say we're going to say it's the same amount. Actually, I'll do the vendor date here. The same, the invoice date, and we'll do the same vendor number, and we'll look at the amount. And when I go to the More button, the last field that we selected is the field where the fuzzy logic applies. So it says here the last field, called amount, is near, and then the value that we're going to use for near, because near can be applied to character-based data, numeric data, or even date data, it applies a little bit differently. In this case, because the amount field is a numeric field, I'm going to look for all transactions that are within $10 of each other. I'll give this a name here. We'll call this same date vendor near 10 amount. And I want to look for the ones that are fuzzy duplicates, not the ones that are exact duplicates. I want to look for the ones that are within $10 that are not, exactly equal. So I'll just take off the suppress exact duplicates checkbox there. I'll just put that on, I should say. When I click on OK, we get two records showing up. And one of the things that's different about fuzzy duplicates is when we do the presentation, it's actually along the same row. So you read it left to right. You don't read it vertically. You read it horizontally. So what I like to do sometimes is just to take the amount field and I'll just drag it over here, since that was the field we were testing for our fuzziness. And we can see here it's the same invoice date, it's the same vendor, but the invoice amounts are within $10 of each other. So we had one record where that was the case, and then in the second instance it was again within $1. In this case, our test of $10 found this record. Now these might be perfectly valid transactions. It might be perfectly fine that we had the same date, the same vendor, and then there were amounts within $10 of each other. But this is just an example of how we can use fuzzy duplicate logic integrated into the duplicates command to check for possible anomalies that you wouldn't normally catch. I'll save the view. I'll go back to my payments table. And this time what I can do is I'll just switch it up a little bit, and we'll look at doing a duplicates test. And this time I'll look at the amount field, the vendor in vendor number, and we'll look at the amount, and we'll look at the transaction date or the invoice date. So we've got the same vendor, the same amount, but this time we're testing the invoice date for fuzziness or closeness to see if we had any transactions that occurred. In this case, because it's a date, it's the number of days. So I'm going to say within 1 calendar week. And we're going to test this. It's going to be the same vendor, the same amount, and it's near 7 date. Again, I'll turn off the exact duplicates. I'll suppress the exact duplicates because I just want to see the ones that are close, not exactly the same date. When I click on OK, again we come back with 2 individual records. We've got the same vendor, we have the same amount within 2 days of each other. In this second occurrence, it was within 3 days. So again, this might be a perfectly valid transaction, but this is a quick and easy way where you can apply some what we call fuzzy logic into your duplicates test, so you're not looking for just same, same, same. You're looking for same, same, near. I mentioned that the other fuzzy duplicates capability, aside from the near functionality, was the similar functionality. And the way in which this works is to look at data that looks similar to each other. An example here to illustrate the point is just the first 2 records. We have 12345 as an invoice number, and in the second record we have a capital I 2345. Now in this case, what we're going to do is we're going to apply some similar functionality or a built-in algorithm that's going to look for these sorts of characters that look similar to each other. And what we're going to do is we're going to take the data, regardless of its type, we're going to convert it into a character-based piece of data. We're going to apply the algorithm to it, and then we're going to return the Levenshtein distance, or the Levenshtein difference between those 2 pieces of information. And maybe the easiest way just to show how this works is just to actually go through and do it. I'll go to Analyze Duplicates. I'll choose the invoice number. When I go to More, I'll choose Similar. And it's perfectly valid to have a similar value of 0. And this is the default because after we apply the similar algorithm, what we're going to do is look for things like I2345 and 12345. And after the similar algorithm kicks in, those 2 will be identical. Those 2 will have a similar value of 0. So what I'll do here is I'll look at the invoice number, and it's similar 0. When I click on OK, you can see, again, we present the information along the same row. And in this case, the invoice number field, 12345 and I2345, would have an exact match after applying the similar algorithm. There are other examples I won't go into of characters which will look similar to each other, but there is a built-in algorithm which looks at characters which visually look similar. This is quite useful if you get your data scanned in through OCR software. Sometimes it doesn't exactly pick everything up correctly, and you might want to apply this similar test. The other thing it catches very nicely is data transpositions. So if you had, in this example, you could look at an invoice number of 12345 and 21345. That would be a similar of 1. So we have 2 different fuzzy tests or fuzzy capabilities. We have near, which allows you to look at the physical closeness based on the actual character data, numeric data, or date data for a particular field. And then we have similar, which will convert all of those fields into character-based data. It will look for things which look similar and change them, and then it will apply a test, a Levenshtein distance or Levenshtein difference on the change data to see if in fact those are matches or not. So we've taken the duplicates command and we've given it a lot of extra capabilities integrated right into the actual duplicates dialog itself. For more information about testing fuzzy duplicates using Arbutus Analyzer, please check the Analyzer help or contact your local support person.